All right, rational exponents are kind of weird, but they happen sometimes. You see them in calculus every once in a while. You don't see them too much, but there's something you have to learn. So you're used to exponents that have been whole numbers or actually integers, right? Like you have seen like x squared, or maybe you've seen like x to the negative 3, which actually means 1 over x to the third. So that's what you've seen before. Even like if you saw x to the 0, that would be equal to 1, all right? But now you're going to see exponents that have fractions in them. So they're called rational exponents because a rational number is a fraction. So when you see a rational exponent, like for instance, let's say you x to the 2/3, right? You could see something like that, and that 2/3 is in the exponent. So this a and this b right here, kind of like the 2 and the 3, that a goes as the power, and the b is the type of root. It's the index. So I like to think to myself that this is the power over the root. And you think the power is on top because it's most powerful or something like that, however you like to say it. So when you see something like x to the 2/3, that's written in rational exponent form. And if you want to write it in radical form, you could write it like this: x to the second, and then you draw a cube root around it. Okay, and then once you do it, sometimes it might reduce, this one doesn't, but like let's say you had x to the, 5/2 or something like that. So that would mean x to the 5th and square root. So anytime the numerator is bigger than the denominator, then you're like, oh, okay, well 2 goes into 5 twice, that could be x squared, and then there's 1x left. So, this can turn into this, and then that can turn into that. So there's like so many ways that you can do this. All right, so now you're going to see, we're going to rewrite some of these expressions with rational exponents and vice versa. So if you saw 15 to the 1/3, that would be 15 to the first power and cube root. So that's like an important little thing to note right there. Anything that has a 1/3 power, it just means cube root. So if you saw 27 to the 1/3, you'd be like, oh, that's cube root of 27. Oh, 3. Or if you saw 8 to the 1/3, that's just cube root of 8, which is 2. Okay, same thing goes with a 1/2, right? If you saw like 9 to the 1/2, that just means 9 to the first power square root, so that's 3. So anything to the 1/2 power just means you do the square root of that thing. Okay, all right, so over here, 8 to the 2/3, so that means 8 squared goes inside, and then you have a cube root. Well, 8 squared is 64, so that's the cube root of 64. And I know how to do this. I know the cube root of 64 is 4. Now, another way to see this problem is this. I could think to myself backwards. I could say, do the 3 first, so the cube root of 8. So the cube root of 8 is 2, and I know I have to do the square of that answer, and 2 squared is 4. So, you can see it a couple different ways, but either way you get an answer of 4. And so if you have like a big problem, like let's say you had a problem like 27 to the 5/3. Well, you're not going to do 27 to the 5th because, oh my gosh, like that's gross and you need a calculator. But you do know the cube root. The cube root of 27 is 3. And so you basically just have to do 3 to the 5th, and 3 to the 5th might be something easier to do. So, yeah, that's all I'm going to say about that. So let's see. So 3x to the 2/5. So all we're trying to do is like write this in radical form. So that would be 3x. I would have to square it, and I'd draw a 5th root around it. So of course, 3x, if you square it, so the 5th root of 9x squared, and nothing happens. I'm just done. All right, here. So this means this 1/2 power means I'm doing the square root of 4a squared. Well, if I can evaluate it, I do. The square root of 4 is 2, and 2 goes into a2 one time, so 2a. All right, here I have the 4th root of 7, so I could write that as 7 to the 1/4 power. All right, I mean, I kind of prefer 4th root of 7, but whatever. If you see 5th root of x squared, so it's x to the 2/5. So just like changing the format, so it's just getting used to the new style. All right, this next one, you got the 4th root of 3x squared. So you could write this as 3x squared all to the 1/4, or if you choose, you could separate it into parts. 3 has a power 1, so that's 3 to the 1/4. And then x to the 2/4, but 2/4 reduces to 1/2. So both of these things, they mean the same thing. 10 BC, you could write as 10 BC all to the 1/2, or you could say to yourself, hey, these all have exponent 1, so it'd be 10 to the 1/2, b to the 1/2, c to the 1/2. So these last two problems, it's just like this. It's kind of like you're distributing that power, right? 3 to the 1/4. 2 times 1/4 is 1/2, you know. All right, so you're going to do operations with these things just like you always have. So you just need to remember your exponent rules. All right. So when you multiply, you add the exponents, right? And so normally they would have been nice, easy numbers. Like if you had, let's say, if you had like x squared or 3x squared times 4x to the 5th, you'd have been like, oh, well, that's 12x to the 7th, right? So it's just the same thing as before. 5 times 2 is 10. K to the, now I gotta do 2/3 plus 5. Okay, so I need a common denominator. So that would be a 3 down here. And 1 times 3, 5 times 3, so 15/3 is 5. So I get 17/3. So it's the same steps, it's just a little bit more annoying. All right, letter B. So when I do a power, all right, so let's say I had, 2x to the 3rd, and then I had a 4th here. I would do 2 to the 4th power, 16. X to the 3 times 4 is 12. That's my old rule. So I'm going to do that same thing here. I'm going to do 16 to the 3/4. Figure that out in a minute. And then W, I'm going to multiply 1/2 by 3/4. So I'm going to get 1 times 3 is 3/8. Now let's check on that 16 to the 3/4. All right. I don't know about you, but I don't want to do 16 to the 3rd because this means 16 to the 3rd 4th root, or it means 4th root of 16 all to the 3rd. I know the 4th root of 16 is 2, and then 2 to the 3rd is 8. So that's what we're going to do. W to the 3/8. Okay, letter C, division. Division is subtraction, right? So back when you would have a problem like, let's say, 12, x to the 10th over, I don't know, 16, x to the 2nd, right? The 12 and 16 both divide by 4. So you'd be like, oh, that turns into 3, this turns into 4. And then x10 and x2, I'm going to subtract those and get x to the 8th, right? So my answer would be 3 over 4 with an x to the 8th up here, okay? So the same idea. So the 12 and the 18 reduced by 6s makes a 2 and a 3. So I'm still having a fraction. And now I have to subtract. I have to do 3/5 minus 1/2. So my common denominator is going to be 10. So 2 times 5, 5 times 2, 6. So 6/10 minus 5/10 is 1/10. It's positive, so it's going on top. And just leave it like that. When you see fractions for exponents, there's no reason to go and write it as a radical. Like, you don't have to write this as a radical, like a cube root or something like that. Just leave it like this, unless somebody tells you different. All right, letter D. So when you have a negative exponent, I think I showed you that up here earlier, like right here, right? So all I can do here is say, okay, 7 over a to the 1/2. Just leave it like that. And this does mean 7 over the square root of a, if somebody wants to write it like that. And you might have to rationalize it, so maybe you multiply by radical a over radical a, and so you get 7 radical a over a. So all these things are all the same, right? Like this is the same as that, which is the same as this. They're all equal to each other. It just depends on like what you need. So, I mean, frankly, usually you're kind of fine to stop there unless you need to write it in radical form. All right, so one important fact to remember, letter E, everything in here, all of this has a 0 power, so the whole thing is 1. Now that would be different if I had 8x to the 1/3 and the y just had a 0 on it, like no parentheses. This would turn into 1, but the 8x to the 1/3 would stay, so that'd be 8x to the 1/3, right? Okay. All right, last little bit right here. So we're going to write these first two problems. We're going to basically write them in exponent format, right? So I'm going to ask myself, what's the fourth root of 81? Well, 3 to the fourth is 81, so the fourth root of 81 is 3. And I'm going to write this in exponent form, like in rational exponent form. So my A is going to have a 2/4. My B is going to have a 5/4, and my C is going to have a 1/4. Now, 2/4 reduces to 1/2. B is still 5/4, and C is still 1/4. So that would be the best I could do. Here, the fifth root of 32 is 2. I have x to the 3/5. Remember, power over root. My y has a 1, so it's going to be 1 over 5. And my z is going to be 10 over 5. Well, 10 over 5 is 2. All right, so now here somebody wants me to write this in radical form. It's already been reduced, and it's in exponent form. All right, so I look here, and this is a clue right there, right? That 1/2, remember that 2 means square root. So I'm going to write a square root problem that comes out to this answer. So ask yourself, what would go here? The square root of what makes 5? And you're going to say, oh, well, 25, right? And then x, there's a 1 here. And if you want to, you can draw this little 2 right here to kind of help yourself out. All right, my y. I need a number here that when I divided it with 2, I got 5. So what divided by 2 made 5? And so hopefully you're thinking to yourself, 10. And for my c, same thing applies. What did I divide? I'm sorry, over here. What did I divide by 2 to get 2? Well, hopefully it makes sense. 4 divided by 2 makes 2. So this must have been 4, all inside that